So, Jacob, how's it been? We've been out of touch recently. We wanted to touch base with what you've been up to. Why don't you start giving us your spiel with all this fan base, because they're really excited about what you've been doing.
I definitely have been watching the Thunderbolts project very recently. I'm really excited though about what I'm working on now. And I think it really goes in line with stuff that's been coming out on Thunderbolts project, so it's definitely really, really sweet.
All right. And congratulations, by the way, with the reference on the Gaia network with the episodes that Dielectric Universe is getting. We kind of got you in the first episode there.
Yeah, they did? I didn't even hear that.
Yeah, they in the first episode they were mentioning Wall was directly talking about electrical cratering being done in the lab, and they used his experiments in reference, and even gave his name out there.
Well, so, I told you that was my biggest thing, that if we could do anything with any stuff that we do, it is this aspect of low pressure or rarefied gases, and then ionizing them. You actually have the potential in controlling pressure to basically control the scale almost of the model. This is where, what's his name? Peratt. I can't believe I just said what's his name about Anthony Peratt. Dr. Anthony Peratt from JPL Laboratories.
You should smack yourself.
Thank you. Just. Welcome to the June 2nd edition of The Electric View. I'm Neil Thompson. Today we have Sean, Will, Robert, and our special guest, Jacob Gable. In showing us his latest experiments, we deduce even more possibilities for devastating catastrophes with water and current, as well as new insights as to what our ancestors may have seen. Please take a moment to like and subscribe.
I think that's my CO2 plasma that I was making.
Yeah, it sure is. It's the one you just came out with.
And, so I picked up the CO2 because Mars and Venus both have CO2 in their atmospheres.
That's correct.
Even Mars is actually thinner than the vacuum experiments I've done. But I'm going to try to replicate some really high pressure CO2 discharges on surfaces to see if I can form the arachnoid feature that's found on Venus.
Oh, the spiders?
Yeah.
Right.
The spider around the middle.
Really at this point, I think Wall Thornhill's been quoted, and there's numerous space news episodes about, Venus. Well, there was one specifically where talking about Mars having craters and Venus not having any craters. I think it was something about the missing craters.
Of Venus?
Yeah, and so that's kind of what this is based on, is that, the presumption that a high pressure...
Didn't Wall say that Venus is a baby? That's kind of why it lacks the craters?
Yeah, that's... Yeah. Well, that would be according to impact theories, because it would take a long time. But it has a lot of dendritic features, and the carbon dioxide and nitrogen, which we have a really high nitrogen atmosphere, they seem to act really similarly, so it already seems like it's going to do well. Just how to specifically get their arachnoid feature, I don't know. And there's some other kinks I'm going to have to work out, because I can't really get up to like 16 or 14,000 psi. It's kind of a lot.
How much psi?
Venus has about 14,000, about 1,000 times greater than.
Yeah, there is nothing on Earth that will have that ability to hold that pressure in. Pressure is not unlike. This is actually kind of interesting when you think about it. Pressure is not unlike electrical tension in a way. That's the same danger exists. If you are, for example, just trying to weigh something of a different charge, the fact that you're touching it will short it, So, especially if a significant charge difference. But the same thing happens as pressure. 14,000 psi is incredibly dangerous on Earth. Not so much on the surface of Venus, because everything is at pressure, if you get my meaning.
Oh, yeah.
And it reminds me how we think that certain animals can't survive in different pressures. We know that pressure itself will change the consistency of matter that it is in. So why would electrical tension not also do the same thing, like thermal does? These are all very interesting questions that no one touches on. which maybe you can. But still, let's start smaller.
Yeah, I don't know. Pressure. To me, pressure, I kind of think of atoms because they have different states that they can be in, the states of matter. I think that those states of matter are actually kind of like changes in the direction of the charge potential or whatever. And so that's why, solids are basically unidirectional, and a gas pushes on all sides in all directions, and liquids will kind of, roll around and fill a volume up a little bit.
Yeah, like a cat.
Yeah, but I think it's possible that you could, calculate all that stuff just by directions and fields and have some sort of sweet unified field theory. But
well, yeah, I think we might be a bit far away on that one yet. But
I think we're close because people are understanding now that matter is kind of structured. Well, at least I guess I do.
Well, obviously matter structured, yes.
The universe kind of builds itself based on the way all the matter interacting with each other, not just single events happening. It's all one big event.
Well, actually, I wouldn't doubt you. I've often said that one of the few ways to describe the universe would be something along the lines of two areas of charge, if you can imagine, infinitely larger than the infinite universe. And the universe itself is just a spark between those two different charges going off. A double layer breakdown. Or it could also be a cell growing. You never know, because we've seen, who was that gentleman? Sandros was on there, Robert. And he was showing that when he showed that thing where you could see half of Laniakea, the star structure, and then he said, and here's
was
the
I
other
on that
half.
episode, or did I miss it from class? Because I don't recall. I think I was only Sandros' episode. I think I was there for like 10 minutes.
It's all good, but don't worry about that. Let's get back to this. So,
right, back to the subject.
Obviously, we noted with William Sosa's video that you can actually have, when you put mercury, for example, in one of these tubes, it doesn't attract, it repels when your hand goes near the tube. We're obviously know more about the attractive properties when you use hydrogen, and I guess this is CO2, you said?
Yeah, CO2.
I like how it has a different bottom. Notice the head is pink, the body is gray, and it seems that you can change how much of that tube. And you also notice that you're getting near the neck there, where you see the stack built up like you just did there, and now it's purple at the end. But you notice how you're getting lines in it?
Yeah.
Those like that right there. That's your I guess it's called cathode dark spaces and stacking, which is not unlike the pillar that you would have seen. If obviously going slower than that, up into the sky above the North Pole when it looked like the ladder to heaven, if that is the case. You could probably model it right there if you just flip that on, like we flip this to the side and then put something that looks like Saturn at the base of the bottle, and then of course a sort of a basketball-like shape at the other end, just to cover that up like a half moon, and you could picture what it might look like connected to the Earth, what they would be seeing, and
that would be intense.
Well, it's an imitation, but we have some friends recently that we know, Chris Barak, for example, who does glass blowing. So you could you could probably make a glass shape in any shape that you want to create the effect that you were looking for, and then film it, making sort of Stairway to Heaven videos and so forth. Not that you have to do that. Just an idea comes to my mind, because it looks exactly like this. I mean, I picture that stacking. So
I want to try. I had this idea where I would set up it would be similar to the Sapphire Project, where they have, I don't know what they use, the anode or something to simulate the sun.
Yes.
But then I would use other electrodes and I would also try to photoionize, because the sun, if it's electrical, it has all these electrical properties, but it's also doing photoionization with the.
Well, yes, because you're shooting out anytime. Like that was one of the concerns that people have with regards to going to the moon, passing through the bulk of the Van Allen belts. The radiation basically turns, because the energy around you has to be dissipated. There's no atmosphere, and as I've explained to people before who are arguing about 5G stuff, as much as be concerned, I understand that, but at the end of the day, we mostly behave like big sacks of water with regards to RF frequencies. So, basically, you'd be in your own microwave oven because you'd basically be cooked.
But yeah, I just thought it'd be cool because I think you might be able to better simulate how atmospheres work if you're using electric fields and photoionization to try to create like double layers and stuff in plasmas.
I think you're right, but we also have the disadvantage of being inside an atmosphere ourselves, so we'd have to, because the heat, for example, of this is pulling, every time a lightning bolt goes across, it heats up and then rises to the top of the glass, because that's the problem. But if it was, for example, the other way around, you'd have a different effect. Not saying you have to, but I'm giving you one of the things that you mentioned was putting something in there. Have you considered getting a lot of ball-bearing magnets?
That would be sweet.
And then putting them in your attached to the side by string, perhaps something that wouldn't be affected by anything, and hold it there and keep it suspended while you have this, see how the plasma behaves with those spheres there and how they go around it. I bet you'd see some pretty neat ring effects, like Tesla noted. But that's just speculation, of course. So.
I could probably hook up a sweet electromagnet or something.
Oh, now you're having some fun there. You can get, if you're going to go that way, you could probably wrap wires around this thing and do it. You can control the shape of it by playing music through it and play music through the coil, and then watch the plasma behave to different songs. If you really want to go that way, so an analog version of
that'd be sick just to listen to smoke on the water.
But that's what I mean, because we know that, and I shouldn't be talking so much. I want you to be talking, but I'm just so amazed by what I'm looking at here, because just the visuals of thinking about what that would look like to the people on Earth if they were down near the neck of it, right? And you're trying to look up this into the sky. One of the things that would, come to mind is the magnetism that you mentioned. How would it behave? And of course, we hear the humming. I think it affected the ground. Like we like the drums, like that was a big thing. Cultures, all over the world have this rhythmic type of music was always something of the gods, and we imitated it. That's always been said. So I assume, or maybe I shouldn't be, that sometimes when these things were hitting the ground, their vibrations and so forth would have resonance effects on the entire Earth. And it would be like the Earth is either groaning or singing or having a beat, and they were imitating that. So it wouldn't surprise me if doing something like that would also be very entertaining to a combination of two birds with one stone, as it were.
Yeah. Yeah, this is a sweet Krypton and CO2.
It's beautiful. Like I said, I'm just having moments of inspiration just looking at it. But that's all it is? It's just Krypton, CO2? What?
Yeah.
You have a plate on one end, I assume, and then on the other, and then the difference is how many volts?
Well, I'm just using a Tesla coil. But
a real Tesla coil or just a transformer?
Tesla transformer. It's like SSTC, Slater Exciter. But so CO2, being that Venus, has been considered a comet, and yes. CO2 in the low pressures looks stunningly creepy because it forms these really dark, diffuse discharges that you can't really even see unless it's really dark and stuff. But it looks definitely, there's like hair and stuff looking. It's weird.
Have you and this is to capture that? Have you considered maybe even though our eyes are not seeing something, perhaps you're seeing it's going into the ultraviolet? It sounds like it's crossing into deep purple. Is that what's going on?
I don't know. I think it could be the carbon possibly doesn't want to emit as much photon energy or something.
Well, it can't emit it, but
yeah, I guess so. How that stuff works.
Well, no, I mean the power is obviously coming from the voltage difference, but I mean how it reacts inside the plasma obviously is not what you expected. Taking or.
Oh no, I was sort of expecting that because I'm trying to reproduce these features on Venus based on sort of Velikovsky's ideas and stuff like that, and to actually see the CO2 plasma and have it sort of this affirming effect of where it does actually look and can have these strange like hair-like fiber effects and stuff, I think definitely goes along with, I guess you could say the Medusa, but it definitely...
Oh, I see what you're saying. And now, do you have a variable pressure here, or is it just, like, you haven't had the ability to change pressure and voltage on command, like with a variac or anything, eh?
I can only just remove the pressure or kind of add more gas.
Okay, so you do have a pipe rigging to it. Okay. Well, the reason I was asking is because with those two options, you could change the volts to amperage ratio, and you could also change the pressure, both of them live. The ideal, of course, would be to perhaps maybe if you did actually put one of these, if you were using ball bearings, and I mean some of them magnetic and some of them not, which one would get a tail first would be kind of nice to see. Depending on how you do the VA, because that's what it's all about, really. The VA curve determines whether or not this goes, like right now you're on the edge of glow mode, just about ready to go into arc mode. I can just see it. You're there because of the way that's behaving. If you were down too much, you'd hit if you turned it down enough, you'd hit a certain point where you were, it would flicker rapidly because you would have the, it would be in that region where it's just ready to go into dark mode. You start getting coronal glows and stuff. And of course, if they have different one, you go to arc mode. And of course, to get it to arc mode would be harder and harder with less and less pressure, because obviously it doesn't want to do that. It wants to be, yeah. Well, ideally, in our atmosphere, luckily, thank freaking God, our atmosphere is right up to the bottom of the top first cloud layer, is pretty thick, and it causes us to. The only thing that can get through it is basically a tornado and lightning bolts. And that's it. Nothing else can get through. We're protected. But obviously, you start going above that, and you get into less pressures, and this is what you're going to start looking like. And that's why we see sprites up there, and beyond that, the northern lights and so forth. It's because it's the same energy, but instead of hitting larger areas because it's in glow mode, the same amount of current, just in wider surface area. And as you begin to go further on the VA curve, you push it into further and further, what's called, what is the word that is used? It is, It bifurcates or it furcates or it wants to get into fibers. It wants to turn into tendrils. It wants to reduce its surface area, and that's where you get these lightning bolts and so forth. That's why they turn into tubes, basically, because if you look at the VA curve straight up, it is.
Isn't that like a dendritic pattern?
Well, you're right, the pattern. But what I meant is that it wants to. God, the word is right on the tip of my tongue. It's like using the Thunderbolts video.
The actual
Thunderbolts is the God one. Yeah, it's when you look into space and we start seeing Don Scott. I can hear Don Scott saying it.
Right.
Well, no, instead of being clouds of gas that we thought it was, they were fibers, they were tendrils, it's a synonym of that. What is the word I'm thinking of? No one has it?
I'm drawing a blank too.
It wants to turn
Filaments?
into filaments. Thank you, for frig's sake. It wants to filament. Jesus, why was that so hard to think of? Like I don't know. Like I don't know. Maybe I just came from work. I'm going to blame that.
We couldn't help you.
I know, eh? It's terrible.
I was actually distracted. I'm feeding my dog right now, and I'm just
It's quite all right. But the filamentary nature of the plasma is such that it wants to filament to reduce its surface area. That's why it never wants to be a glow, and it turns into these wonderful shapes because of that. Now, no one can argue that they're beautiful, but your ability to change those that parameters would be fantastic, because if you could do that, then you could go, okay, on the correct scale, here's Venus. On the correct scale, here's and you could add some dirt at the bottom or whatever you're doing, and it could be quite cool.
Yeah. I should be able to get up to 900 or so, like 800 psi, but I don't know if I'm going to be able to do breakdowns in that. I still haven't experimented with that, but I think I might. If I have to, I'll just get a really, really ripping Tesla coil that can do it, and then I'll use that to
how many watts do you have?
Plasma, kind of like.
You can actually calculate it out.
I don't think I would be able to do it, but yeah, I mean CO2 breaks down a little bit better than atmosphere, the air.
You can actually go into. Oh well, yeah, okay. You probably looked it up on Wikipedia or whatever, but yeah, you can look up the dielectric strength of any material. But obviously, pressure changes that significantly. So,
yeah, I didn't think of that.
Well, you could actually calculate. Like this is the engineer in me. But you can, like for example, what you're looking at on the screen here is this wonderful distance between these 2 points. You have this much voltage, and the potential breakdown. Actually, you could measure the breakdown on just because the distance between those 2 points, and that that many volts is divided by that many things is this many volts per centimeter or whatever, volts per inch. And then you could use that to look back onto the chart and figure out the dielectric strength of the gas that you're cooking.
And how much voltage I need.
Well, you can also calculate the amperage through it, and you could all this is all related. That's why I'm finding it very interesting, because if I could, I'll see right now. I'll take it in a moment, but please go play the video there or play whatever you're going to do. I'm going to get you the dielectric strength of any items or any gases. Dielectric. It's basically what a lightning bolt has to break down. Why you can't go too close to certain items, and why you wear rubber when you're near certain things, because the dielectric strength of rubber is phenomenal. But when it breaks down, you would never think that it can break down, but yeah, like Jupiter blowing the pieces off of anything. If you had two planets, it doesn't matter what the material is, it's going to be broken down.
What do you guys think of Ben Davidson's micronova? Or his, I guess I don't really consider it micronova. I just would say a nova event.
I don't. It sounds catchy, but what really are we talking about here?
Well,
I linked that thing for you there, Robert, or who's ever in control.
I guess it plays in with the worlds in collision theme, but more that the sun cyclically basically has these outbursts where it will, there's huge plasma events, or
scroll down a bit.
The sun will start ejecting matter, which I thought it was really interesting that
the sun will eject matter for what?
Well, because it's like having this nova event where the plasma basically, or the energy going into the sun, something is happening to it, so now the sun is basically cooling down and starts ejecting matter. It's like expanding and stuff. I don't know.
No.
Oh, I think you're talking about the concurrent nova events is what he's talking about. Is that what you're talking about?
Yeah, he calls it the Earth catastrophe cycle, I think.
Yeah, he's trying to relate those somehow.
But I actually thought it was really interesting that he said that, because I had a theory that kind of happens to the sun, and that it basically, well, in some of those experiments I was doing, when I would kill the plasma and there would be these eruptions, I just assumed that if the sun was a plasma and something were to happen to its power source, I mean, you could bet your bottom dollar it's going to eject something.
Well, I can explain that too. But this is your chart right there, if you want to know. And by the way, this is why your fingers touching that glass. Anyway, so if you scroll up slightly there, you can read just the why it says, so it's megavolts per meter. So a meter is about 3 feet 3 inches. So millions of volts per meter. So that's the field strength, the strength of air, for example, at sea level. And that's probably what the 7 says, at sea level. But that means you need 3 million volts per meter. So when you think about a lightning bolt coming a mile away, that's a god-awful amount of voltage. That's why this idea that it's just the ionosphere,
oh, I know.
There's way more going on. There's this thermal pile effect that Andy was talking about seems to be quite much in play.
Up and updrafts.
Yes, exactly, because there's things going on there. But anyway, if you can see alumina window glass is quite insulative, and so forth. So when you're starting to, so if you want to, then you just measure the length of between your two electrodes, and don't forget that you're basically going to then have you basically divide that by basically just by dividing that into that formula, and you can calculate how many volts it will take to cross that distance, and then you can start calculating, and this is for avalanche breakdowns, which is basically arcs. So it says
high vacuum, 20 to 40 megavolts per meter.
Yeah, at high vacuum. That's what we measured in putting things in. But we know that space is not really a vacuum. That's the trick. It is a vacuum, but it's not it has particles flowing in it. So
I thought you need a lot less voltage to spark in a vacuum.
Well, no, when he says high vacuum, it means literally nothing in it. That's the thing. If there's nothing to carry charge, there's nothing to carry charge. But space, as we know, is filled with charged particles flowing right by the planet. We have a tail and we see the auroras. So to think of it as a high vacuum, no.
Well, isn't it almost kind of redundant or something to even consider then that there is a breakdown in a vacuum because there would be nothing there?
Well, that's the whole point, I think.
It's ridiculous.
Because, to what's probably happening in situations where there actually was a breakdown, because you basically had to get 40 million friggin' volts to do it. It's probably that it ionized so much across because basically what you've just generated is a capacitor. So you would put these two plates close together, and then you would try to, and you pump as hard as you can to remove all semblance of air in anything. But the moment it starts getting more and more charge across it, eventually there's going to be this point where some of the material in the metal will start to sort of ionize and float off of it, which is not unlike what probably happens to the sun when we get prominences. This material is coming up and following these electric fields and then coming back down, likely in a different spot, which likely creates mountains when it happened on Earth and stuff like that. So, because if you want to see what was happening on Earth when events happen, just look at prominences. But a nova event, nova, I don't want to diminish the word, but
I consider it more of I refer to it as the volcanic sun. And it's just a theory that the sun has, its potentials can change, and when they can change abruptly, and then all of a sudden,
of course they could.
It'll get covered in sunspots, and then it'll just start erupting and ejecting matter all over the place. And one of the theories that's where the asteroid belt actually came from.
Oh, like it was a blow off.
Yeah,
I can envision that.
Just raining everything down on everybody.
But that's see.
In fact, I think Wall was making the reference in some of the Gaia episodes that the blow off actually happened from Saturn.
Yeah, there has been some claims on that too, and there's reason to think that because
Venus was actually part of it.
Well, yes, because Venus was born probably during that event.
Yeah, exactly. Yeah.
Because if the sun did capture Saturn, and the Saturn had a significant plasma environment, and all of a sudden the sun just totally stole and equalized it, I mean, it would make sense that Saturn would be responsible for ejecting all this stuff.
It wouldn't equalize it very well. We have very little appreciation for the sheer enormity of space. We see a picture of the sun through a telescope, and we think that's the sun. It's right over there. But it is one astronomical unit away, and it is extremely small compared to the overall surface area of the of its plasma sheath called the heliosphere. Just like we have our magnetosphere, if you get my meaning. So these are like nested things, and each thing has a different charge, and it's trying to equalize to its charge environment. So yes, if Saturn was from outside of the heliopause, just by touching the heliopause, things would quote unquote get real, and there would be a lot of bleeding at that point. The sun would probably freak out. It could have barfed up stuff. That's quite possible. But because the amount of stuff that's processed on the heliosphere should be equal to the stuff that's processed on all of the planet's surfaces, if you get my meaning. Because each one of them, more or less, is processing electrons. It is a load on a circuit. If that is the case, then whatever's happening outside should be processed inside. And the only place that energy seems to be expressed in this environment is on the surfaces of planets and the sun itself, where there is pinches happening, where magnetic and electric fields pinch down onto spherical surfaces, and you get homopolar motor effects and all that stuff. So the energy that is coming from the sun is just also generated from the heat from the light of the sun, but is also the magnetic fields and everything else that's passing through the entire solar system is coming from outside of it. So the sun itself is not really generating anything. So
I just had this conversation with somebody last night.
Oh, you did you? Yeah. See,
Yeah.
Sorry, I'm throwing that out into you then, but
The sun is not powered from its core, but it's powered externally from the rest of the galaxy.
well, once you start understanding how small it is, like I mean, the sonoluminescence idea that I heard by William Sosa is not too far fetched. I mean, look at what we put space weather potentials. Look how close we put those things. They are not remotely that way. The heliopause is over 80 astronomical units away. And if you do the surface area calculation of that, and then you realize that all of that surface area is processed on the surfaces of all the other planets and the sun, you see the sun has the largest surface area. It will attract the most electrons. And everything else is pretty simple from there because you understand how it's going to work.
That is pretty interesting. I've never considered the heliosphere.
Well, yeah, because it has to process those. It has to come through it. We know that there are fluctuations in it. We see it moving. It's pumping. It's vibrating. Basically, electrons are coming out along this the solar wind, hitting the heliopause and neutralizing and being pumped back up to the poles and then back down in. And of course, there's a reason for that because there's a motion of electrons predominantly in our galactic or the galactic arm or our local area, our local chimney, and we are along that. So that's why that's there. You know, it's not really too complex electrically speaking, because there's no, as much as we would like to think of things like you're processing it inside an atmosphere, and you see, like when you turned off your power, and you saw the poof that happens, and that is and I describe that as it's the same situation as when you have a factory, a whole whack of factories in a town hooked up to a power station, and then the power's turned off. Well, all those motors are spinning still, and they're going to reverse polarity of that line and try to keep the connection going, keep the circuit going. So it's going to arc like crazy, if you get my meaning. And that is, now that's what happens at a power station. In your situation, what happens is when you cut the power, it reverses direction of flow, and it has to, and its electric field or its magnetic field, which is what's actually the energy that's being held here. It's called an inductor. You basically made an inductor. I know it sounds weird, but if you actually put a metal core, that effect would be significantly stronger, I bet. If you just dropped, like, had a metal rod in the middle of that, like a piece of, do you have an old coat hanger?
The magnetic field lines.
Exactly. So, well, it's not the lines itself. What you're doing is you're making the magnetic field stronger, because it can have a stronger magnetic field, therefore hold more energy in this inductor. Because what you're doing is you're holding magnetic energy in the magnetic field. A capacitor holds it in the electric field. If you charge up a capacitor, you have a field difference between 2 points, the surface area of which you can calculate the amount of coulombs between the two, then you can calculate the amount of joules it will do. You know, it's like almost like a battery.
Class on it. Now it's starting to make sense.
Thank you. That's how you calculate the surface area of the planet. When my presentation happens there, Robert, you will understand everything I'm talking about, because all it is about capacitors. So, and inductors. So, in your case, though, an inductor, also a tornado is an inductor, technically, then. So that's why it has a strong magnetic field, and that's why it messes with compasses, and that's why when it dissipates, it starts getting wider. And you see it constrict when it gets close to buildings, because buildings are metal, so it's reacting to that, and it's making a stronger magnetic field. There's more energy per cubic or per cross section, if you know what I mean. So in this case, then, if you put a metal rod in there, you could have the same energy, and it will hold more in its magnetic field. And soft iron is the best, and coat hangers are soft iron. So that's all I was thinking. It's simple. You can just sort of throw it in there. And then when you turn it off, you will note that the kickback will be significantly stronger, because it will do way more damage. to the surface of the dirt that you're blowing around, because the magnetic field is being held in just whatever the magnetic field strength is able to do without a core, which is just an air core, and they're not that significant.
What if we are talking about how novas actually occur?
Well, we're actually talking about how prominences break down. We are talking about that, literally, because that's exactly this thing. You have a double layer, which is the sun, and that's a capacitive layer. It's so strong though that anything that even remotely leaves the surface is flung down the gradient field and out along out into space. So this is where you get the solar wind from, because that's how much potential's there. We're talking gigavolts, and then or teravolts even. And that's not even with a storm. And the storms are prominences. And these prominences are twisting of these sort of magnetic fields, and they poke up through, just like a thunderhead might, and then basically break. And when they break, material is moved from place to place. It's not really breaking, of course. It's just realigning, but it will follow the electric fields and create these prominences, and that's from point A to point B. So the same thing should occur on the Earth. We should have, and we do note, a connection between the north and south of our planet over top of the equator. These loops happen at that point, and they could be why we have storms on different sides of the planet. You get double hurricanes coming off of the tropics, going north and south. Those type of things. Because they're literally connections over top of the equator. Ta-da. Like it's awesome, but it's, I want to say it's not rocket science, but I'm now looking at something that looks like a rocket flame, so I'm just going to stop.
Yeah, that was definitely very interesting. What's this talk on capacitors? I think when I was learning about electricity, capacitors were my favorite circuit component.
Well, they're useful. That's why they're one of my favorites. As anyone can tell you,
the strength of the electric field.
Go ahead, Robert. Tell us about capacitors, or Jacob. Please go ahead. So, sorry, he's all excited. So I know he's just learning about it. I just
like capacitors because there is. It's not magnetism, I guess, but it's I'm trying to think of it. I think it's not the Lorentz law, but it's the law for static charge. Coulomb's law, maybe?
Yeah, Coulomb's law. Yeah. That's literally it. Yeah. The amount of coulombs.
Charges in place. So then, you start to build up negative charges on one plate, and they'll actually repel.
Actually, you're doing it right here. I'm watching it. You did that. You're making you have a capacitor right here. The glow on one end is a charge of a different potential than the glow on the other end. Now, the gas between them is your capacitive layer, the one that's resisting the movement of these charges. Now, it's leaking like crazy, because atmospheres do that, but that's okay. It's still working. And that's that you've made a capacitor right there. And when you make the tubes, you're also making an inductor. So, I mean, because it's spiraling. Once it's spiraling, you have a magnetic field, right? So,
yeah.
Ta-da. As Robert can tell you. And
I'm just figuring that out. So, yeah, but it's starting to make sense. I couldn't explain nearly as you.
Pretty strong capacitors. I think Electro Boom made a really strong one.
Well, the Earth is a really strong one.
You can just charge them up and zap yourself.
Well, here you go, Robert. Just to have fun, you can actually now think about it this way. Rearrange the formula for a capacitor to solve for, since you already know the voltage between the ground and the ionosphere, that's 500,000 volts. You know the distance is 50 kilometers. So then you know the plate size because you know the surface of the Earth. So once you have those in your formula, you could then therefore calculate the amount of coulombs on each plate and the capacitance C of the Earth. And that's it. Then you now know exactly how it works. It is literally that's static.
And you
of
do
course.
that just by, because what I did is you do that by finding out your total impedance, and then with capacitors, I think it's negative I over.
Actually, interesting.
Make C, right?
Interesting. You already know some of this because you can actually calculate the impedance because you actually have the Schumann resonance is 7.86 hertz.
Okay,
so you can actually put the frequency into the
kind of looking for there.
Exactly. See, because then you can start calculating the impedance, which is your, and that allows you, of course, next you're probably going to start calculating power factor. So
right, yeah, definitely power factor after that, and then
that's what you should learn because because you're moving into.
Yeah, I was just doing that. I was just
You went from DC, which is the simplest, and then you're moving to AC because now you have to incorporate frequencies because different frequencies will change the response.
Yeah, but my struggle was, like I said, I had technical issues, so I missed a lot of stuff in class. So I had to rush through it. So and he spent way too much time on DC and then like just blew through AC, which I don't think he should have done. But yeah, so it was kind of blurry to me. But yeah, starting to see all this now, it's starting to like click. So yeah, that's why I said I wasn't comfortable with the class. It is starting to click though. I feel better.
Well, you probably saw some of this stuff on a battleship. You didn't know what it was for. Like, you must have had large capacitor banks on a battleship, eh?
Oh yeah, But I didn't mess with the.
Do you know what they were for?
Yeah.
Do you know what they're for though?
Thing.
No, it's literally for one thing. You have a power grid in your battleship or aircraft carrier, okay, and now you have all these spinning machines, your drills, your rotors, all those spinning inductors,
dishes, radar,
all the spinning, all the guns, all that stuff that move around. All of those things are inductors, right? So they're going to move your power factor in one direction. So you want to fix that. So you're going to use a capacitor bank to equalize it and bring your power factor back to zero.
Okay, yeah.
And that's why you have capacitors on a battleship.
Okay.
See, it's
all that power factor.
Well, it's a lot more drain on your system if your power factor's off. If it basically starts messing with all the motors, start getting really weird waveforms. You start getting harmonics and triplets inside of your ship or inside your power grid.
Oscillations.
Exactly, and then now you're giving off signals to the enemy.
You're just wasting volts and current.
Yes, exactly. You're totally wasting your power curve. Totally.
Dissipated in heat.
Exactly. You see it all. It's well, there you go. So that's why they charge you more if your power factor really disturbs them. So that's why factories will sometimes have their own capacitor bank to cope with that. But anyway, enough of me and wonderful stuff about battleship capacitors and power factor. Welcome, guys, to the esoteric electrical knowledge of battleships and power grids and stuff now, because apparently that's what we're teaching. We're not actually showing you cool stuff anymore. Anyway.
This is a learning show.
It is a learning show. But yes, someone else interview this wonderful gentleman. Go ahead, Robert. I don't want to hog so much time because I'm really enjoying this, and it's blowing my mind every time I'm seeing what he's doing here.
Yeah, I love what he's doing.
This is a really good conversation. So
basically, just what's inspired him to start doing all these different, things. Because frankly, I just kind of imitated you. Like I said, I put a post up a while back when I was at the local planetarium here in Salt Lake, and they had plasma tubes in it, and it was funny because nobody was in that section of the planetarium. They were all on the brand new, like, we just found black holes and stuff, and like the time-space continuum sheets. They would stand on them and watch how their gravity would make them bend. And it's like, that was just, the weight scale, basically, and how it would bend it. But yeah, there was nobody in the plasma tube, so I was sitting there playing with them, and I put my hands around them, and, like with the William Sosa's, experiments too.
Right.
Just to see how it would affect it. And you can actually see the plasma actually start to pinch a little bit around in little spots, and then it would kind of fade out. I guess it would equalize around my hand. But it was just a couple seconds like that, and I just posted that. But it was like thinking basically of you and William Sosa's work is what kind of made me do that. But what made you actually start to just start tinkering with this?
Oh, definitely. I think I've always wanted to know the biggest secrets of the universe, and I used to kind of feel like I could only be an audience member. I guess that's how you feel watching Channel 2 or the History Channel or something. And, the Thunderbolts project, when I heard the electric universe theory, it, dawned upon me that it was possible. Well, and watching Carl Willis, watching his video, I just realized that if I can make these or control the pressures.
Look at that! You caught lightning in a jar,
and you shocked yourself, didn't you?
Yeah,
I knew you shocked yourself. I would say that's not smart. Don't do that.
It was going to allow me to do something with or have more knowledge about the electric universe.
I'm going to give you a hint right here because I'm going to tell before I go any. I'm sorry because I don't want to forget it. If you want to save yourself a lot of shocks because you shouldn't actually be doing half of what you're doing near this thing, take a little bit of electrical tape and just wrap it around the top of your Tesla coil so when your arm accidentally touches it, it won't shock you. Because trust me, the field will go right through it. So the field doesn't care about your electrical tape. So you can wrap that whole tin can right up if you want.
Yeah, and
not that it's as dangerous as actually having, because I know what you're doing now. Tesla coils are not nearly as deadly as actually trying, if you had the other end hooked up to a ground wire, if you know what I mean. And then, you know what I mean? So anyway, continue, please.
Billy Elverton was another huge, seeing him create so many things, I just seemed possible. And Thunderbolts project guys, they're getting older, some of the founders, so they're not going to be around forever to carry the message, and people still don't seem to be wanting to change. It's like dragging a horse or whatever.
I'd actually see it that way.
I'm still nammering on about electric universe, and they'll be like, "Oh, is that so?" And it's like, "Oh, I've been telling you this for years, guys. Come on."
Well, it's not them that you have to convince. You see, it is
It's got to be.
What we're really doing is there's a group of people who are going to go to school and become the next generation, and they're going to say that they were inspired by things they didn't really understand. People talking crap. They will barely remember half of the real things that were said. They'll only think of some of the crazy things that you see, but across, and I shouldn't say it like that because I don't want to diminish it, but there is obviously a bunch of people that you can see who have their own take. And as I mentioned, people will bring their own stuff to a new paradigm because it reinforces their beliefs. That's just the truth of it. But that doesn't necessarily mean that there are not a group of people who are being relatively rigorous and diligent and simply stating the facts of, hey, this is plasma, this is electricity, EM in space. That's all I'm saying.
Is because they're still going on about black holes, that's
right.
Where
but they will always.
It's never accepted.
They will actually only because an event will eventually occur that was not unfamiliar in the 1700s and 1800s and 1600s when they saw absolutely crazy stuff, but they're going to see it with high definition. They just landed on Ultima Thule, which should not exist, but yet it does. A peanut-shaped planetoid with 3 moons electrostatically connected to it, not orbiting correctly, out past Pluto. What? No, they don't believe that. They have to because it's real, but because they land like this. This is there. It's there, but
this cannot be.
But it is. But so, for example, we've already seen evidence of a prominence ejected from Venus heading towards the sun. So that was a nice thing that they saw. Now, of course, that was not up close and personal. But once something happens that they have to accept with regards to like a comet that actually discharges to a planet. Like if that happens, when it's not going to hit it, it was not going to hit it, but it caused something to occur that was significant on the planet that said it looked like it formed a giant aura that came up and reached up and then touched the comet, and then the comet exploded. Okay, that would be hard to dismiss.
Yeah, that would be a massive breakdown.
Yeah, but I don't anticipate that. If Shoemaker-Levy hit on the side of the planet that we could see, things might already be different.
Oh,
yeah, would have been.
Because the amount of... we know how big the explosion was because we saw it glowing off the moons. So, we're talking a comet that broke into several pieces, 9, I think, or 13, I don't know, and then slammed into Jupiter with the force of apparently on the vicinity of the other side of 1,000 megatons or more, like a gigaton of explosive. That's impossible to fathom mass doing that to gas. See, now if we saw it, it would be something we would be still trying to figure out.
Didn't Jupiter also have its auroras flare up before Shoemaker got there too?
As it should. But it also flared up when Tunguska happened as well. So, like, before it occurred. Like, I read that many years ago, probably in the 90s, and my brain could not process how energy could happen at a distance like this. What is going on? I could not fathom it. And I was already electrical technician at that point.
Dr. Shoemaker was kind of puzzled too, and yeah, because I actually had the pleasure of meeting him. So.
Well, now as an electrical engineering technologist, and when I went into great detail, as you probably will, Robert, that's why, because you know that it touched the barrier crossing into our magnetosphere. Well,
right.
Then the comas touched. When the comas touched, they transfer energy. At that point, where is the energy going to be expressed? Anyone? Class?
At the poles.
There you go. Or the surface of the planet. I was going to accept that too. So basically at the surface of these objects. That's where it is expressed.
Yeah, and then it would,
that's where it's first expressed until it can get one of these going. Once something like this happens, then it has a connection. But it didn't do that until it hit about 7 miles. And when that happened, well, there goes 30 megatons. So.
What'd you guys think of Andrew Hall's?
Oh, I love Andrew Hall's work. I was trying to get David Brown on this one because he's been narrating it for Andy as well. And he's not available. But it'd be cool to have you two together.
Yeah.
I honestly did not see it. Can someone explain it to me what his main crux was? And I only say because I've been, as you know, incredibly busy.
What, Andy Hall's work?
Yes, I have it lined up, and it's sitting right there for me to watch, and I just haven't hit play yet.
The Eye of the Storm? Well, he's been basically working on, because we had him on the...
oh, yes, I know what we talked about.
That's basically, it was just more in depth on that. He was basically using the features of Jupiter, like the eye spot, and explaining how we at one time had storms like that shaped our the surface of our planet. And he just goes and uses the southwestern United States as a prime example for that.
I assume the Utah, like the spiral that was noticed by Steinbacher there in 2014.
Right. He said it was the eye of the storm. Like there was, the cyclonic winds, highly charged, that just seared the surface and blew it around like putty.
Yeah, that would be crazy.
Crazy.
There was something like that actually going on.
I would like to also help if you can get some perhaps carbon black, or like from a toner from a printer, or you could use, or that's slightly magnetic though. The other one, actually highly magnetic. The other one, which could imitate iron, that's why I chose it. The other one is like a liacodium powder, or something that's made of spores, something that's incredibly fine. And then you could have some interesting cratering effects that would be layered and fine. Because I mean, every time I see it, I'm amazed that these bottles that you're using are holding up so well too. Have you considered getting a bigger one?
Yeah, I tried making a bigger one,
and it broke in.
And it didn't work out. I don't know if my vacuum was not powerful enough or it wasn't. I still have the chamber, and I can't remember what exactly. Well, my vacuum gets all messed up because I suck in so much sediment. So I still don't have a filter for that, and I've been thinking about redoing the experiment inside the wine glasses, but I don't know. It's just...
Well, you could use, for a filter, you can use practically... I wouldn't go with that, perhaps, but like a bounce sheet. I mean, it would smell fresh.
Well, oh yeah. Can't have it, because the bounty sheet might catch fire if it's got arcs going on it.
Oh, you'd have to put a screen. You need a metal screen for like a hookah or something, or a pipe, and then you put that over the thing, because flames can't pass through it. It will ground it out to the frame.
Yeah, and I do have...
Sorry, I keep forgetting that I'm trying to be safety oriented. I just go ahead and stuff that in there. See, this is why I got to be careful. Here's advice. You killed everyone in the house.
I want to make a really large scale version of the experiment. But this chamber that I want to buy for it's like $500. And then I would need a nice vacuum pump for that, and I would want a turbo pump so I could get it high vacuum really fast over and over again. And I'd want to be able to protect the pumps in time.
Well, I can understand that.
I'm definitely going to be doing it. I'm really focused on this Venus one because I just kind of see if we can. The Thunderbolts, I think, could use some more experimental evidence for their collage and stuff that they're working on.
Right.
And now, you have, low pressure craters formed with electricity, and now we have these dendritic features, so you can say that both Mars and Venus were resurfaced by an electric storm of some type, and to suggest that the Earth wasn't anywhere near there would be ignorance, essentially. Considering
we are between the two of them? Yeah.
We're sandwiched in between these two planets, and if their surfaces were reformed, then the features on Earth ought to have been resurfaced too in some sort of way, because Venus has a way higher pressure.
If you look really close, you can see the Israelites on one side, and you can see the Pharaoh's army on the other. Get it?
Yep. I'm going to laugh too. Ha ha ha.
Obviously, I don't mean, I don't even regard whether or not anything in any book is particularly literal, but the pillar of fire motif, look at this. And you can even see the ripples. It's beautiful. And it's burning a hole right through that because it's found a nice spot, I see.
Earlier on, it had actually a bullseye crater inside this one.
Well, that's the thing. Usually these things
had the charge dissipated. It left it.
Yeah. We know what happens when the moon has no atmosphere, and we can see the arcs on the moon, the craters on the moon, have more of those bullseye effects and stuff like that. But you have, but Mars also has much longer trench-like features and topography differences, if you know what I mean. I'm not saying that the moon isn't interesting in any regard. I meant that just you can see that although similar, the characteristics of the two planets, one having a thin atmosphere and one having practically none, is different compared to us having a moderately thick and Venus having a super duper thick. But the super duper thick, what we see on Venus, I think are birthmarks. And they're not unlike probably the birthmarks of Earth, which are probably where our cracks are now that the Earth expands from, if that theory holds true. So, or at least the fault lines, whatever you want to call them. But we know generally where they are. Well, those on Venus are sort of like the tendrils around the equator. It's not unlike you might see around a geode. Of course, planets are very, very smooth spheres compared to geodes with their general bulk in the middle, because the electric force to create a sphere of that size means that the magnetic force is going to be nearly spherical. It's going to have a small oblateness to it, which we seem to note that most planets do. We think it's because of the spin, but if they're more solid than we think, maybe that's not the case. So.
Hey, Neil, what's this center spot remind you of?
Is it oblate? What's that?
That's
inside this crater. What's that center spire remind you of?
Well, it looks like a bullseye.
Well, it's like you see on the there's a layer and then a layer. It goes down and then down, if you know what I mean. But I think you were pointing out something in particular.
Yeah, the center of it has just been burned out, like a Playful Dome and some other craters.
It's interesting, though. Something similar to this then would be if you want it to be something interesting. Jacob, I would probably go for if you wanted to do something that scientific theories would pick up on. If you could get that fine dust to leave black trails as it goes along, I like how you can see the two currents right beside each other, bouncing back and forth.
Well, forming a rim crater, peanut shape.
Yeah.
Possibly how it formed the low.
Well, if you turn it off right now, then when it was in a different shape, but now it's trying not the. Sorry, don't worry about it. Don't have to stop it. Like right there, for example. That's ideal for a perfect. If it continues longer, then one's going to get bigger. So we know now that the idea that these things are impacts. We could see how they were formed, and the ridge is right there, and I bet you we could see the ejecta shooting out both sides like we did. We do see on the moon craters of the exact same type, which we see. You see how it's piling up on going out the sides, where we see the slosh of the on the moon. When those two craters that we see side by side that are said to be impacts. But
yeah, I think the rim craters come from there's so much rotation happening in the plasma.
Well, remember, plasma likes to travel in twos, as even though you're only seeing one at a time, there's two currents there. One's in dark mode and one's in glow mode right now. And the reason that you're seeing two is because, remember, they want to travel in pairs. So you have an inductive one and the main current beside it. Okay, so this is your positive negatives, like a twisting snake going right on up there. So that's what's going on here. Now, one's stronger than the other, and it'll bounce back and forth. Not unlike in a pulsar situation where the two fields are sort of bouncing off of each other, and they have a rhythm to it. At least at the beginning. Once you change the current, or the one finds a better spot to burn through, finds a lower point. You know what I mean?
Sometimes it's so accurate that I feel you could kind of do a scale ratio and even degrees on angles of the craters, and they would still line up pretty precisely. How the hexagonal craters form. Yeah, and there's still the other outgassing and bubbling going on.
Well, it's not. outgassing. It's literally Coulomb's law. Coulomb's law says that a force acting on any particle, any grain of sand, is equal to the constant K and the Q1 and Q2, or the charge difference between the 2 points, and or the electrodes, basically, over the distance.
If I were to, because I have a vacuum pump running, if I were to actually kill the plasma, that the crater would still boil and bubble like that, because the water in there is actually vaporized.
Okay. I didn't know you had water in there. But still, obviously you're going to get way more gassing if that's the case. Yes, totally. It's going to boil the crap out of that stuff. Yeah.
And there's like way larger craters when there's water present, or I guess any liquids. Which I don't know if anyone's ever considered this, but there is so much oxygen in our solar system bound up in stuff like carbon dioxide and oxides in planets.
And stone.
It's everywhere. Absolutely everywhere. But how come it's just so weird that we have so much fresh oxygen here? Blows my mind. That's where I think this whole, the whole storytelling comes into play, where people are trying to tell a story of how we got oxygen from microbes and stuff, but...
Well, you're making it right here.
But, I mean, I think nobody really knows.
I bet you dollars to donuts, the material, the constituent gases of the atmosphere is changing as you do this.
Look, Neil, you're getting a central spire in there.
I'm making all the O3.
But you're also creating ozone, yeah. But you're also, for example, when you saw a bunch of craters form, those 6 craters, like right now, there's so much gas coming off of that this is where it wants to be. But before, it was finding spots. You know what I mean? And we've seen that where there's a shotgun pattern across the surface of the Earth. Even we have that. So you can see how fast it could happen. You think, oh, it's all happening over there, and then suddenly, blast! Places unrelated are now suffering. Well, maybe not suffering because we don't know who was there, but
yeah, and Eugene Bagashov, his videos that he just released are really awesome too. I don't know if you guys watched those.
It's lined up.
Yeah, he goes in depth about the porosity of like Mars and stuff like that, and some of the moon.
Oh, yeah. He's pretty much a fan of your work too. When you came out with the CO2 podcast just recently, he was pretty excited about it.
Oh, nice.
I noticed that Will's here too. Hey, Will.
Yeah, definitely gets me excited. He's talking so much about the ancient catastrophe, and yeah, I'm really excited to try to support it more with this.
What ancient catastrophe is he referring to? Did he have a different theory, or is he just referring to?
He's using stuff. He's using orbits of bodies in the solar system and how they show that there's possibly like a planet 9 or planet X. He says maybe that these assumptions are wrong, and it actually is evidence of a catastrophe that happened in the recent past, and where planets were actually crisscrossing paths or whatever, coming in close contact with each other. And he talks about the porosity of the surface of Mars being, it's like a solid, homogeneous, porous object, so that he's suggesting that it's formed electrically, basically, or was electrically scarred. I guess you'd have to watch the videos, because he goes...
Well, no, that makes sense.
He's pretty good.
I like how you see the scalloping on the sides of the crater already.
Right?
Yeah, the scalloping. Yeah, I almost was about to start firing up the old wine bottle, but then the chamber I was making for it just broke or whatever. And
so we do appreciate all the work that you do, Jacob, because
well, yes,
hard
of course,
make it all happen while you're trying to do this as a hobby, you know.
But it's very brilliant.
I know. If only Birkeland could see it now.
He'd be very happy, I'm sure. This is like it's inspirational because to see what you can build, especially if you could put different sizes of conglomerates, because obviously where the light is where things are going to be lifted the most. But breaking open an aquifer, like this is basically what this is suggesting, is that it will reach for these aquifers and it will vaporize them. Which will cause, so much more devastation. Earthquakes, like you wouldn't believe if you vaporize an aquifer. Like overnight, or not overnight, sorry, in instantaneous, like this.
Oh, good Lord, I never thought of that. That would,
Well, yeah. I mean, you're going to have a wonderful, it's going to basically, it's going to be attracted to the ground. And as it does so, it's going to burrow through, and it's going to, as we know from the experience of blue holes and stuff like that, it's going to reach down to a particular layer. Once it finds that layer of highly conductive rock, that'll be good. If rock is going to heat locally, of course, not so bad, but water will change to vapor quite quickly. Don't get me wrong; we see the effect of this in these pipes, these burrowed, what they called vugs. Remember we were talking about that many months ago, I think. Can I see this chat message? Yes, I can, Will.
That's Will the electrician, right?
That is correct.
Yeah.
I'm not in a audio conducive environment.
Well, still,
okay.
I can still
It
hear you.
happens.
It's cool. We're good.
Good to have you on, though.
So now I guess you've already burned through, or you turned off the power here.
I think I was slowly taking the power down to try to avoid any
Kickbacks like that?
Yeah, it just bubbles a little bit.
Yeah.
That one.
There is a beautiful crater on the rim of a crater.
Yeah.
That started off with a bullseye crater and two craters.
When I look at that landscape right there, that reminds me of that one that Andy was showing us down in Mexico.
Right.
That it's looking at a perfect example of like, here's a volcano over here, a large
Mars
blackened area. Yeah. And it's just, and could you imagine though, if it hit an area and blasted the aquifer underneath and just bubbled it up and the material just goes flying everywhere. And of course, then you have a rearranged landscape. Whatever was there is buried, gone. Like, the catastrophes now. I have the ideas that what we're going to find underground. Like, I have no faith in any geological dating system when you see that.
Yeah.
It's like, no, the layers indicate age. Bull crap, look at that. Those layers indicate, oh my God, this happened that took what? That was about 10 minutes? That's how long that takes.
And it could be the whole surface too.
Yeah, well, it's only being held in spot, of course, because obviously if it was an incoming bullseye that was highly charged, it's going to move across the surface. Two planets are going to obviously pass. We see what happens, or we think we see what happens when we look at the Google Earth and you get to see the ocean bottoms and you can see that there are lines across it. Now, not the stretch mark lines. I mean these crisscrossing lines that don't seem to make any sense. If you go look at them closely, they appear to be little crater chains. So we're talking about something that moved across the surface of the planet in a directional way, and then doesn't get too close to the surface of the land, because once it gets close to land, it's going to jump to it. So it doesn't it doesn't get close to land. It jumps from like hundreds of miles away from the land to the land. So, yeah. So that's a very interesting situation when you're trying to imagine there was enough power to burrow through 5 miles of ocean. So.
Yeah.
And then put a crater on
I don't know
bottom.
if you know the discovery that Saturn's rings actually has ice that's similar in like isotopic composition to the water here in the oceans on our Earth?
It should, because it pulled a ton of water away from our North Pole. According
Isn't
to
it like the deuterium ratios or something like that, similar to Saturn's water or something?
I think that was it.
It'll be the spectrum. Ratio. Yeah, they're going to see the spectrum. Yeah, I get that. But which would tell you if it's deuterium and the ratio between that and hydrogen or H2O. But what I meant is that if the Saturn theory is right, it's just one of those things. When I say it like that now, it's so banal, or whatever the word is. Just like we saw in that image earlier with the bottle that he was holding on its side, but if you imagine that stuck into the Earth, the neck of it into the Earth, where the spigot is there. If you see that, and then you imagine what it was doing to northern Canada, you can see the results of it. It totally devastated everything up there and carved Hudson Bay looks exactly like that thing that he just made. Like that one we just saw a moment ago, that great big huge bay, like it looks exactly like Hudson Bay with a crater on the rim. That's exactly what it was. And and they crisscrossed Baffin Island. They just etched it to little crap. And then all the way to the fjords, all the way across Siberia, that whole area was engulfed in one of these currents, just like this. And it would have been vaporizing water, removing land, and throwing it upwards. In fact, it could be argued that the rings are made of parts of northern Canada and Siberia and all those places, Greenland.
Yeah,
it could have just been crushed in the powder, like what David Brown was showing.
Yeah, it would have been, I think, and then thrown up into there. Some of it, turning into rocks as it gets up there, because it will be recompressed into things as it pops through. But still, eventually becoming orbitals and so forth. And that's just an interesting concept. But the water is so nice to see as a further confirmation.
Yeah, and when we have because we have dendritic features that are supposedly formed electrically, but then also, the large you were talking about. How do you think we would have gotten a large crater if we had high pressure? Or I guess in my opinion, I would think that a large crater like the Hudson Bay would have formed when we had a lower pressure, like at the very.
Well, it's not considered a crater, so that's very important. They don't think it's a crater, but the reason is because it doesn't seem to have the characteristics of a crater, like the one that they just discovered under ice that does have the characteristics. But what it does have is this, not unlike the, for example, on Io, if you look at the Tel Vashar volcano, it has moved, the cliff face has receded, if you get my meaning, by 20 miles or something over the last year. Now, this cliff face is a mile or two tall, so it's basically being literally etching that surface away as it continues. And it's processing. It's just like this burn is moving across the landscape. It's the same type of idea. As its connection to Jupiter causes it great agony. You get my meaning, and this is a similar feature that you would have seen as it would be not every part of that was carved at once. I'm assuming it was just like this. It was a continually over, like this connection by like the late John Cook's estimation happened between 5800 BC and 3100 BC. That's one of the estimations of that connection being present, and of course it would have happened before that in certain times. So that's at least a 2,000-year burn. Get my meaning? So it doesn't necessarily have to be as devastating as instant. But the instant ones are much more likely to be the Lichtenberg figures that you're finding, or burning across the landscape like Lichtenberg figures do, if you get my meaning. Which would be basically because there's two arcs coming from either side of the planet that is now connected to another planet, and there is charge wanting to get from across the surface. And as it does so, it burns Grand Canyons and such, which is,
But then, like, like Mars Epinacati, that's more of like a circular. I guess it would just be way more current or something, is what I'm guessing.
Well, current. If you increase the current, you're going to get more into arc mode. So that's going to be your main lightning strikes, of course. But if you're lowering it, you're going to get something that's going to be prolonged pillars of fire. Because if you want to think about what you're looking at right here, for example, that's different than what it was moments ago. There you go. So, but you'll have a central column. Maybe they're equidistant, or they're trying to form a distance from each other. It looks like a tree. This would be sticking up out of the northern pole of the planet. It would be burning along those edges, or everywhere touched along the rims, carving out the fjords, etching everything around, and of course boiling water from the oceans. And of course, if there was planets like the size of Saturn up there, a bunch of water would be rushing in that direction anyway, because the tide would tell it to. So
that wouldn't be a fun day.
Well, that's when it connected, and of course it would connect. That would have been that could have been, younger Dryas that time. So that could have been massive floods then, when it connected, and then there would be massive floods when it left. So.
Yeah, the floods. I definitely believe there was a big storm.
Well, you're looking at it.
Yeah, it's interesting now, because the evidence kind of is there. The Saturn water, electrical scarring, stuff like that.
Well, it doesn't have to be exactly that, but it does definitely have a lot of merit. One of the things that the mythological era has is that mythological context without meaning, action with avarice and capriciousness, with no regard for human existence, people praying and hoping with no end in sight. And then 2,700 years ago, suddenly it was Plato, Confucius, Lao Tzu, Buddha, Siddhartha, I guess. Everyone started thinking like us, like what happened? And what happened before that? Like when they weren't freaked out, because there were times when they called it the Golden Age. What the heck did that mean? And this is where this remembering the Golden Age stuff from David Talbot, which I shouldn't just say stuff like that, but it has...
Yeah, slap yourself again.
Thank you. It has merit, because you see that there seems to be a time when we really, really, really worship Saturn, and why? Why is that? Why that's a thing at all?
Yeah, I think we were actually we were like a moon of Saturn, possibly.
Well, it seems that we were underneath of it, in my opinion.
And,
polarly connected in its donut.
And so if you can imagine if we had Saturn dominating our sky and the sun was also there. So like if we were orbiting around another planet and the sun was still in the picture, nobody would have been able to come up with a heliocentric model. Because obviously this, Saturn would be there and the sun would be there. And I think that would actually change the whole entire structure of like spiritual hierarchy, if you will, of how we feel that because right now we're like, yeah, the sun is the center and that governs our solar system. But if we were a moon of a planet, then that would basically be we would have two sets of hierarchy. We would have this planet that we're around, and then there's this bigger thing that's out there, if that makes any sense. And that's where I think some of the mythology, why it's so different than what we see now portrayed.
Oh, for sure. Number one, if any of this is remotely true, or and there was this, there would be a lot of debris. And we've often talked that the idea that the sun was depicted by Horus as Horus's headdress looks would mean something significant, because that's not the sun we know. The headdress is very particular and depicts a red sun with a yellow outline that they called the Urea serpent, and it had prominences coming off of it like the sun does. So that means the sun was dim enough that with our naked eye on Earth, we could look at it, see that it had prominences, and we could identify them with our eyes, which we could probably do because it's about the size of an aspirin at arm's length. If we could see it without going blind. Now, that would mean that the sun was that red that you could do that. See? You would see the corona as if it was in an eclipse state, but all the time.
Couldn't there have also been a different atmosphere that would have produced a different colored sunlight?
Sure. But that would not allow us to... If that was the case, we would be dead. Like, for any length of time. Like, it would be a disaster. And every time... And we do have evidence that when that happened, and it did happen, in 535, for example, we know that on the Rovina mosaics, that we see depictions of a bluish sun, of very vibrant skies, shock waves going through the skies and stuff like that. And it said that the famines lasted 9 years. The plagues and all that stuff. The Justinian's plagues. So this is the bad stuff that happens when that's happened. So this was probably not that, because no one looks at Osiris and goes, ah! So it was a long-term thing. Probably because of dust in between us and the sun. And Jupiter, and after the clash of the Titans, there would be more of that. That would be very scary because the floods would have happened again. Things would have washed over everything, and these two fighting gods would have traveled out into space, doing their duty, doing their thing. Well, what's going to happen with that debris is going to have to get cleaned up, and it's a conductor. So it's going to make it easier to shock planets, and the tail of Venus would be much brighter, and it would be sweeping through there, and that dust would be eaten by that and projected right along the tail and projected out along the solar wind. Eventually, it could probably be cleaned, so to speak, till the sun looks like it does today. And this might explain why we only saw blue recently, because the skies were kind of reddishly purple.
I feel like you should write everything you just told me down in a book, and you should publish it. That's like, you seem to be able to tell it very well.
Thank you. But there's a combination of people who talk about this stuff. I like it all, and I try to be fair that there's different ways of explaining this. So I'm not trying to be dismissive of the idea, but there's certain things that seem to prove or lead towards this idea that there was actually something at the North Pole that, besides the damage we see, we seem to have these floods that washed over, and it would make perfect sense because, here you got this huge friggin' bunch of planets above you. You're stuck in this magnetic bubble below it, sort of like, spinning around in this, like a donut inside a donut, and you can't get any closer, and you're sort of bouncing there, electrostatically drawn along, and then suddenly, Jupiter just about hits the darn thing. That they, clash the Titans. Oh my friggin' Jesus! There's this, Gorgons and all this crazy stuff starts happening. The 100-handed, I don't know what the heck that would even mean. And then
Saturn actually has a warm spot at its pole too, which is kind of interesting.
Well, that's the thing. These things are highly charged bodies, and they're still obviously quite active. But they didn't. They continued fighting, doing their thing out there. But we were left, we only had a memory of that. Like that, the cultures prior to this are different than the cultures after this. They were really kind of terrified. It's a different way of being, and they were like that for thousands of years. And the atmosphere was highly charged still, so they were probably still freaking out during even the time of Abraham and all that stuff. So. And of course, the messengers, the gods, were still running around. Like Mercury was still off course; it had to be because it was still flying back and forth. And Venus, we were being very, very careful about that. And apparently, we could predict when the disasters were coming. We built underground stuff to protect ourselves from it. It's very interesting.
Yeah. I was doing some research on Mars.
Oh, that's beautiful.
And I started getting into this Atacama Desert in Chile, I think it is. And it turns out people like to film, or they use this desert because it's so similar to Mars. They use it for NASA uses it to simulate stuff for their missions. And so this desert is full of these. It has perchlorates, which has even been used for fertilizer. They would refine it from the desert or whatever, the soil. And Mars actually has a huge concentration. Well, it's not huge, but it has perchlorates in it, perchlorate ions in the soil. And it's actually toxic to humans. But I thought that's really interesting that we have all these. Well, some of the deserts actually contain a lot of perchlorates. So I don't know if it's something to do with deserts obtaining perchlorates somehow from the sun, maybe. But
I think
that's how
parts of Mars rain down on us for sure.
Yeah, that's what I think. Is that possibly even Chile? That's why it looks so much like Mars and has this similar Martian soils, because it might even be Martian soil. But
the interesting thing we have to understand, though, is that as much as we might think that it's going to transfer the way that we think it would, like just the surface of Mars is going to move and become the surface of Earth, like electroplating. That only works when you have one material. Mars' surface is made of silicates and iron-bearing rock. And as such, when it transfers from planet to planet, it will electrically separate. That's why we get these different layers. You have layers of silicates laid down, then layers of rock falling just below it, and so forth. And that's why they look like that, because it's been sorted, basically. It's not just time that's sorted. It could be those many events could have happened just one after another. And we've gone on many geological expeditions to show that you can see inclusions of stones from the layer above in the layer below, indicating that this was a layering effect that was raining down, and these balls were coming in and then got stuck that were precursors of the main layer that just came after it. So that
you can also see different layers that are just going in jagged, diagonal directions, crisscrossing.
Like one was cut right off and then layered again. Yes,
another blown right into it. Yeah,
yeah. These are the shock waves that will just blast a layer right off and then, at an angle, like straight.
I was just by some limestone formations. It's like a river gorge we have out here, and I'm looking around for quartz veins and stuff, and I see these big, huge ones that are they're like about the size of 2 softballs or something. They're just quartz. Like it looks like a lightning bolt went straight into the rock or something and kind of melted.
It probably did. Well,
Or
quartz is made of silica, and then you have or silica is made of quartz, but you can withdraw it from it and form a new lattice, which lightning could probably do. Crystallization is obviously something it's quite capable of, but that's why probably, as we discussed before, that gold appears in quartz veins. It's just withdrawn and pulled into that.
You'd also find like uranium associated with silver veins and whatnot, right?
Actually, I'm not sure, but that would not surprise me.
We were talking about that with Ito because he said that you'd usually run into I think it was uranium after you were mining silver, and that was kind of like the
because they were two combined.
It was like bad luck or something if you ran into the uranium because like you're done looking for silver once you find that because it ends.
Well, because you're not going to die, yeah.
Right.
So it's like, was silver double silver is uranium? Is that what he was?
I'm not sure if he said that it could be, but I'm not. I think that's what he said is after you're mining silver, you'll run into this black stuff. I can't remember what they call it, but it's not a good term. It's like a bad luck term that you run into because you ran out of silver now. Basically, is what it means, and it's a uranium. But they didn't have any need for it back then. They weren't making nuclear bombs back in the 19th century. So.
Oh, so they didn't know that it was.
Yeah, they had no need for it. It was just they were looking for silver and silver only.
Fair enough.
Little did they know.
Right.
Some of the greatest stuff.
Well, actually, yeah, a lot of it comes from. There's some mines in Canada that have uranium in them. We have a lot of a significant amount of metals, but when you think about what was going on up there and it only recently got covered in tundra and dirt. Canada's just inundated with that, and lakes and water. Which makes sense if it was all being held up and then suddenly just left and then saying sloosh, and it created flooding, like the swamps of they were the frozen swamps before, and now they're just flooded out and frozen tundra.
Yeah, this is a sweet.
Didn't Wallace Thorne have a video? It's pretty old now, and he showed it that way, and I was like, wow, just Saturn leaves and then it just goes bloom. You guys remember that? Yeah. I don't remember where I saw it.
It also explains the instant death of all the animals.
He was talking about Venus and Titan being born and stuff. Yeah, Wall Thornhill he's a mind blower.
No, Venus and Titan being born. There's his theory is that they were born at the same time from the same event because usually these things happen in twos, and they both seem similar. If they weren't on different orbits, like if they weren't one not at the far reaches and the other one close to, and plus being close to Saturn would ground it out a lot faster because it would lose its electrical power a lot quicker being right beside Saturn. So probably a wife of Saturn or something.
Titan is the only other rocky planet in the solar system that has a nitrogen atmosphere like the Earth's, and it's 1.5 atmospheric pressure, so it's fairly close.
Yeah, that's pretty good. We could do something with that.
Yeah, that's where I think, being that it's around Saturn, and this idea that we were around Saturn, and it's so similar to us, I totally feel like it's starting to paint a picture for me,
Well, it certainly does for me. Just getting an idea on some of the implications and how it. I mean, just looking at what you're doing here on the ground, you can see how it's a different surface. It goes for the high point, then goes straight to the water as fast as it can.
Yeah, and
I wonder if we would have been able to see if we would have been able to see with like a dark mode plasma or something, if this would have been what was happening in the Mount St. Helens.
Well, what I like most is that
Like, to
stuff
some
is
degree.
falling into it. It's falling into
It looked like
this
the whole
connection.
mountain just melted instantly, and it didn't look like a whole bunch of magma just poured right out afterwards. So I think it was either some kind of harmonics or electrical thing that we didn't see that just kind of like liquefied that whole side of that mountain.
Oh, it was off center. Whatever if whatever is the magma chamber, whatever is this, and I think it's basically like ball lightning, a torus of energy powered by the either the harmonics of the Earth or something that's giving this thing its pressure power, but it's self-reinforcing. It's cooking everything around it. It's like a big welt. Material is shot out just like it is shot out here, and then it falls around it, building up this caldera. But now, of course, this is different. But this one obviously has a thing. But the thing that was in Mount St. Helens, it pushed the side, and then it sloughed off. Now, what happened there is that it became exposed. The eruption in one direction was lateral, obviously, but it had the character of, you see the fine dust immediately coming out, because that's everything getting vaporized, okay, really quickly. So this is that, just like all these electrical etches you're seeing right here. There's a bunch of material being just turned into very fine dust and thrown up into the air right here. Well, and not just the stuff you see raining down; those would be boulders. But anyway, the fine dust, of course, ejected out, and then it shorted, and all of basically, you have an example of that, of Jacob, of that when you turn off the machine and it does its thing.
Yep, there is one called Extinguished eruptions, I think.
Okay. Well, in a similar fashion then, when Mount St. Helens, that ball in the middle shorted itself, the torus, whatever that ball lightning was, once it shorted to the ground, it no longer had an insulative cover across it. It shorted, and all of that magnetic energy that was being held there released. The inductor popped, and pow, the volcano exploded. And that's it. If I'm right. If we're correct. But I don't know. That. We don't stick our heads in volcanoes to look, right? So, plus, it might not be right, because there's connections from magma to this thing. Like, it's already grounded out, maybe. Maybe I'm wrong. But is it generating its own power? There seems to be something that's making it happen there, you know, and it happens in a ring near points that are, well, seem to be a place near that they want to process electrons, because you can't get through that water. The water is an ocean. In the ocean, you can't get through it. But you'll run into the nearest land that's near it, and you will run into a volcano to ground out through it. Well, maybe that's the situation, but unfortunately, way more research is needed, clearly.
Yeah, volcanism. Well, I don't know. Because don't a lot of the big volcanic explosions occur as a result of contact with water?
But well, they're trying to explain the magnitude of the problem. See, the magnitude of the problem, if you've ever, I think Robert, I showed you that video we were watching ago, and the guy, you could see the pressure wave come off of the volcano when it erupted, and the people on the boat, the captain said, "Here it comes."
You gotta wait for it, and then boom!
Yeah. And you heard it. It was like guns going off. That's not a popping sound. That's not a pressure release, you know? That's a short, that's a bang. Like, you're off, you know? But, again, we're trying to estimate what it is. I mean, the dust being very fine is a big clue, though, I think, to me. And, of course, the fact that this dust is highly charged, attracted to the ionosphere, and has lightning going through it, another good hint. But what do I know?
Yeah, well, maybe I got rid of that. The extinguished eruptions. I might have got rid of them.
Oh, that's quite all right. I mean, as long as we understand what we're talking about, that's all that matters. But when you have something turn off like that, like the current just drops, boom. Because it's going to reverse polarity, because it's no longer being powered. And it's going to, basically, that magnetic field is going to collapse. And whatever energy is held in it is going to have to be released.
It's the kind of stuff that keeps me up at night.
Well, it's just called inductive kick. I mean, just goes. It's an interesting effect, and you see it when you try to turn off a substation. You see those great big electric.
Was that it right there?
Yeah.
I'm sorry. Did I miss it? I'm sorry.
Resurfaced. And
looked like he turned down the power, and it just.
Well, he was trying to turn it down, but the magnetic field will collapse, and once it does, it's going to change the voltage polarity, and it's going to then have to what it's going to do is spinning around itself, because the charges are going in opposite directions. You have two currents going in opposite directions, and it goes poof, because there's some gas in there, of course, but the electric field or the magnetic field expands quickly. It just
you even see that spin.
Opens out. Yeah, it opens up, and as such, it's going to create huge circular vortexes.
This actually creates a porous surface too, and the whole looks spongy. You can kind of see it.
Oh no, I see it. It has like the characteristics of like a cake.
Yeah, the gas just flows out in spongy channels.
Well, as soon as you turn it off, it's suddenly the connection between those 2 points is not the power source. The power source is the magnetic field, and the magnetic field is only going to be there for a very short period of time because it's expanding rapidly, because it's going to go poof, they're going to fly apart, because keeping that turn to spin around each other takes energy, right? So they can't have that anymore. So it's going to fly apart, and as it does so, it's going to there's going to be material that's along the surface that is susceptible to being electrostatically moved, and it will be moved by those spinning forces as they fly apart. So
plasma is so elusive because okay, sometimes I'm confused. I mean, when I'm looking at, there's a small glow in there,
mm-hmm.
and how much. Is there still gas in there that's not ionized, or I guess that's where what part of, where does the plasma start and the gas end? Or it's kind of...
If you want to use the most hard, firm version of plasma, then you would have gas over 5,000 degrees thermally created is technically plasma. Mm-hmm. However, that's obviously not the case. If I'm using the loosest version of plasma, then the loosest version of plasma would include metal. Like metals would be plasma. Yeah. Solid plasma. Because you could this field that you're doing right here, you see running up the side of this thing? You could also map that inside a wire. So you can see it twisting around itself in a wire. Well, if that's the case, then it follows fields that it's self-reinforcing. Therefore, you have a plasma in that metal, and therefore anything that is able to conduct at a certain and it can flow would technically be a plasma. So lava would be a plasma. Clouds technically would be a plasma. Dry snow would be a plasma. Dust on a desk could be a plasma technically. Smoke on a cigarette could be a plasma.
Well, wouldn't they have to actually be freely exchanging the charges though? And that's why a conductor would be kind of considered
not freely, loosely.
Loosely.
It doesn't have to be very conductive. It can be loosely conductive, somewhat conductive. As long as charges can flow with relative ease, you'll start getting patterns. And this is what you're seeing here, right? So,
yeah.
Well, there was that kid at the middle schooler that Ben Davidson just mentioned. I can't remember his name. I think it's Curtis Walsh. Walsh.
I
Anyways,
don't know.
But he's the student that just won the national science championship using the solar forcing models.
Nice. Yeah.
Using what models?
Solar forcing. He was basically using how solar output affects storm formation, like hurricanes and cyclones. And he was climbing up in all kinds of like science fairs. He won the state championship in I think New Mexico because he's from Santa Fe. And then that gave him entry into the national championships, and he just like smashed it. He won it. Yeah.
Wow.
He's like 14, 15 years old.
Well, the other thing that was discovered by an Australian student who was like 17 years old. She's the one that discovered those bands that go from the northern hemisphere to the southern hemisphere across the equator. Those plasma tubes that we can detect but cannot see. But then suddenly, you get that picture from that observatory and saying, "Well, tonight there's a night fire going on." What? Excuse me. What's going on? Night fire, like the sky is alight with these ribbons of color that are going north to south.
Right.
They're red in color, are they? Yeah. Oh, what a surprise!
There you go.
And you happen to be on the equator? Well, we're really close. Okay, so you do see them sometimes then. See what? Never mind. Talking to someone else. Go back to your space observatory stuff. We appreciate your work. Keep it up. Send us good pictures.
Eat some more crayons.
Well, no. They did go to school for that. It is actually hard. But
okay, let's just say they were Marines and eat some more crayons.
Well, the end result is that when you're forced to live inside a paradigm and you are not necessarily driven home the scientific method, like engineering doesn't necessarily teach the scientific method per a unit of course, but it teaches you, hey, your calculation's wrong. That means it don't work. You're wrong.
I like that post just put out this morning. Yeah, that was really funny. 1 minute it took to say that. Yep.
Yeah, that's it. It's all it takes. So when you guess that there has to be dark matter to make up the matter you can't see because you guessed wrong, you're wrong. So get a new theory. That's it.
Yeah,
that's it. There's nothing wrong with that. That's how science works. But like you said,
there's too much money involved in it now. Well, they can't.
Exactly.
It fit. And the hubris involved. Yeah.
Yeah. The trouble is that guess what? And I'm being very honest here. The guy who invented gravity as a concept, Galileo, and invented the telescope, okay, and then like was put in jail or whatever bad stuff happened to him. He was rolling and dropping balls and coming to interesting conclusions about the way these things worked and how they fell and the weight didn't matter and stuff like that, these concepts. Well, that took nothing but balls and dropping them. Then Newton codified them into formulas with the help of basically all of Europe at the time to do it as they were figuring out what the hell to call forces and such. But
and didn't you say Kepler did his experiments with like a barrel and a broomstick?
Yes, that's exactly what he used. Kepler defined orbits and the power in orbits by the fact that back in the day, they used a stick to measure how much was in a barrel, but the barrel was on its side, not on the top, like not top down, it was sideways. So when you stuck the stick in, how did you know that you were getting an accurate reading? depending on where you put the stick. And by
Right.
using that math and the layer of circle that you would be touching as you put the stick in, he used that mentality, that knowledge that he learned from brewing to infer that the power in an orbit and the speed in an orbit is equal to the cross section of the triangle you make on that orbit. And
Right.
that's how you calculate the speed of something on an oblong or elliptical orbit. And as such, now we know. And all because he uses stick and a barrel. So you're using a...
So Jacob, you should be proud that you're in the kind of group with these people, because you just grabbed a bottle of swill and some outside dirt and hooked it up to a circuit, and you're doing amazing things here. I put you in the same realm as those
that's, yeah.
beautiful minds.
Because
you had the
that's it.
vision to do it,
And of course, a hat tip to Birkeland, because anyone seeing his wonderful contraptions with the Torella inside, but he wasn't thinking about geology. But hey, it's a logical step, and I've had the idea myself, but I always thought that I would have to try to get an aquarium and all this stuff and the machines. I don't even have something to do this with, if you know what I mean. And I wasn't in a position to do it. But here, someone like yourself goes, oh, you don't need all that. Just whiz this together. And suddenly I'm like, well, I'm a particular idiot, aren't I? I could have done this long ago.